All right, good morning. Thank you for attending today. I have a pleasure to start the hardware management track. My name is Kasper Wszolek. I'm a principal engineer at Intel. I'm mainly responsible for the manageability architecture of hardware and firmware solutions on Intel server platforms. I prepared this presentation with my colleague Jan Sowiński, but he couldn't attend, so I'll be presenting myself. So the DC-SCM 2.0 specifications have been successfully contributed to OCP back in 2022. However, the real success and kind of a holy grail of those specifications is to achieve an interoperability or certain level of interoperability between different vendors, either vendors of the DC-SCM modules or the vendors of HBM modules. And we believe that a common understanding of what DC-SCM compliance actually means and how it can be measured is a key to achieve this certain level of interoperability. And in this presentation, we'd like to gauge the interest of the hardware management and hardware management module subproject in working on such a common definition of compliance between the DC-SCM designs and defining the compliance framework as well. And here in this presentation, we also want to share some of Intel's learnings in enabling DC-SCM 2.0 designs, as we were kind of the first enablers of the DC-SCM 2.0 modules. So we've enabled DC-SCM 2.0 designs for internal debug and development very early in the specification development phases. As a result, we were playing kind of a catch-up with the specification progress. We presented the first prototype, the one that you can see on the top right-hand side. It was very early in the specification progress, roughly around 0.6 or 0.7, where we built the first prototype. And the last one that we built is on the bottom right, is the version that is already fully compliant with the final version of the specification that we contributed. And we also showed that on the Global Summit last year in the Experience Center, as well as this module was also part of the DC-MHS system that Intel presented. So we'd like to share how we handled the early bring-up and testing of those modules internally. So we have built a simple standalone bring-up board for the DC-SCM modules that is presented on the diagram on the right-hand side. And this bring-up board allowed us to primarily supply the power to the DC-SCM modules in the standalone configuration, but also allowed us to break out some basic interfaces out of the DC-SCI connector and also have this LTPI pass-through that I will mention on the next slides. So this made a pretty decent bring up and testing and debug environment for us. We were able to test some basic DC-SCI interfaces like I3C, eSPI, SM buses, and if you combine that with the additional debug headers on the DC-SCM module itself, as well as the standardized I/O faceplate interfaces for the DC-SCM, it is very useful setup to execute a lot of testing on the module itself without even going further into the integration with host processor module. You might have noticed that we had those two DC-SCI connectors on this bring-up module, and this was for the purpose of interconnecting two DC-SCM modules together. And this is our major development vehicle for integration and testing of the LTPI interface, the LVDS-based tunneling protocol and interface between the two CPLDs that are sitting on each of the DC-SCM. It's not a real use case, but it is really handy small setup that allowed us to test and develop the reference implementation that we actually contributed to OCP like 2 weeks ago. And it's you can download the full reference implementation of LTPI by Intel from OCP Resource Center, Design Resource Center. in those early bring-up phases and also in the later on when we integrated the DC-SCM with HBM modules, we heavily leveraged the OpenBMC firmware capabilities and Linux capabilities in all the testings that we did. We internally defined like 30 checkpoints that we ran against every new DC-SCM prototype, which turned into around 80 plus test cases that we executed in order to pass the integration criteria. And while those tests were mainly manual and only automated in a small scope, what I want to emphasize here is that we didn't do any OpenBMC firmware modifications at all, or Linux modification. We just leverage existing tools and methodologies to execute all those testings. And also we think that the OpenBMC firmware itself and the overall Linux subsystem capabilities provides a lot of goodness that can be leveraged in compliance testing the DC-SCM modules. And this is kind of food for thought for the next slides where we are talking about those compliance testing challenges. So what are the challenges that we see? The DC-SCM 2.0 introduced alternative functions in the DC-SCI pinout. And you can see that on the right-hand side diagram where most of the pins on the DC-SCM connectors will have some alternative interfaces associated to those pins. This makes it, this allows for multiple combinations of those functions on the pinout, which is making it harder to achieve interoperability between different designs that use different combinations of those alternative functions. And in order to address that, we are currently working within the DC-SCM work stream on narrowing down the number of those combinations to standardized HBM types, so that we have just a few types of those combinations to make it easier to achieve interoperability. However, even in this case, and this is what I meant by this diagram on the bottom, is even if you have a standardized pinout configuration and you want to achieve interoperability of a one DC-SCM module with multiple vendors following the same type, you still need a common agreement on what compliance with this type actually means, right? This is what we want to address in this presentation. So what we observe is that in most DC-SCM designs, the BMC SoC itself will have either direct or indirect access to most of those alternative functions that I mentioned in the previous diagram. And I marked them in this slide with a green color, the ones that are accessible by the BMC SoC itself within the DC-SCM. So it's kind of very tempting to use the BMC to execute testing on those interfaces. Based on that, it seems that BMC SoC combined with OpenBMC firmware provides a lot of flexibility through the OpenBMC capabilities and direct access or indirect access from the BMC SoC to those DC-SCM interfaces, especially combined with out-of-band capabilities of the BMC and out-of-band APIs like Redfish. It seems like a good engine to execute compliance testing. So in order to build a common compliance definition for the DC-SCM and common compliance testing framework, some certain principles need to be aligned between vendors and captured in a common DC-SCM compliance testing specification that would ideally be developed within OCP community and agreed together. And in order to leverage OpenBMC firmware in the compliance testing framework, oh, sorry. A common DC-SCM 2.0 awareness needs to be defined within the OpenBMC firmware itself. It includes the Linux device tree, alignment with the DC-SCM, the devices mapping to the DC-SCM interfaces, I mean devices within the BMC SoC, as well as resources mapping to those BMC interfaces. And we think that this common standardization of the common configuration file and standardization of this configuration file, like a common source of truth for the definition how the BMC and OpenBMC maps to the DC-SCM is a key in achieving that. And those type of configuration files, it's even either an XML or JSON-based or any other metadata-based files can be used to also generate the device tree configuration files for Linux subsystem, and also could be a source of the compliance testing framework generation and execution as well. So following that thought, we'd like to discuss two options or examples that we think that could be followed in the compliance testing framework. Excuse me. That could be followed in the compliance testing framework using OpenBMC. So the concept on the left-hand side is using those, on the bottom, it's using those configuration files to generate a test framework that is kind of a self-contained and built-in on the OpenBMC. It can be executed automatically or as triggered through out-of-band, but then those results are reported back to the manufacturer, to the vendor, or to the entity that is doing the compliance testing. On the right-hand side, we follow the the same proposal, but in this option, this whole framework is used to build a compliance testing API instead, so that all the logic of those compliance testing can be actually executed externally and just leverage the compliance testing APIs to do the job. And while those are not all the options, we think that we were discussing internally this type of concept, but we are primarily interested in community's interest in following this compliance testing definition. We're not trying to push any options here, just share thoughts on this problem, and we are looking for feedback and other ideas as well. So there are other considerations in compliance testing as well that I didn't even touch in this presentation, such as mechanical compliance, thermal and power compliance, electrical I/O, signal integrity, LTPI IP compliance between different implementations of LTPI, as well as the notion of the built-in self-testing for LTPI that could be integrated in CPLDs. So, sorry. So there are a lot of considerations to be addressed in this compliance testing problem, and we think that the OCP NIC is kind of a good example to follow. I'm sorry. In the excuse me. In the OCP projects, with its because this is a mature project and it already followed all of this kind of compliance evaluations around the module designs and so on. So we think that there's a lot to learn from OCP NIC 3.0 in the context of compliance and validation. So for the call to action, we are looking for others that are interested in defining those the compliance criteria for the DC-SCM 2.0 and building a common specifications for compliance testing and common framework. And we are open to all sorts of alternatives and different thoughts on addressing this problem, primarily looking at other companies that are interested in collaborating in building the frameworks and building the specifications around that. So please free to reach out to us through Hardware Management Module subproject. There's a mailing list, and there's also a monthly public call if you're not a CLA member, or reach out to us directly to Intel. So that's all. Thank you. So are there any questions? We have like 4 minutes.
Will be shared somehow the reference design of the Kawashu for DCSM module?
Yeah, we are not planning to contribute any of those designs that I presented, the DC-SCM. If there's an interest in leveraging the bring-up board that I presented, the small module, Intel can consider contributing those type of modules to OCP if there's any interest. If there are no other questions, thank you so much.